Now we completed the polar plot. Now in the another frequency response of the open loop transfer function, then one more plot is also available, that is nothing but the Nyquist plot. Okay. Now students, now this is the Nyquist plot, and you know that the similar thing, Bode plot, polar plot, Nyquist plot, all are the frequency response of the open loop transfer function. But before we start the Nyquist plot, I just give one comparison between Bode plot and Nyquist plot and polar plot. This is Bode plot and polar plot. Then I write Bode plot and polar plot at one side, and I can write Nyquist plot at another side. Okay. So what is the difference is, in Bode plot and polar plot, we want to find first gain margin and phase margin. Gain margin, if you want to find a gain margin, we require phase crossover frequency. If you want to find phase margin, we require gain crossover frequency. So we want to calculate gain margin, phase margin, then we decided the stability of closed loop control system. Stability of closed loop control system from gain margin and phase margin. But in the Nyquist plot, then the Nyquist does not depends upon this gain margin and phase margin. No gain margin and no phase margin. The Nyquist not calculating gain margin and phase margin, no gain crossover frequency, and there is no phase crossover frequency. But he decided the closed loop control system stability. Closed loop control system stability directly without gain margin and phase margin. This is the main advantages of the Nyquist plot. No gain margin, no phase margin, no gain crossover frequency, no phase crossover frequency, but he can find the stability directly without finding gain margin and phase margin. And the another important of Nyquist plot is, the Nyquist will give additional information. The Nyquist will give additional information which is, the Nyquist will give additional information which is not given by any other plot. These are the two important points such that the Nyquist plot is important rather than this. No gain margin, no phase margin, all lengthy calculations are eliminated. He finds stability directly and he gives the extra information which is not given in these two plots. Understand or not? So this is the main difference between this Bode polar plot and Nyquist plot. Okay, note down this. Okay, so this is the main difference between the Bode plot, polar plot and the Nyquist plot. Okay, because of these reasons, now this plot is very famous. So keep these two particular points in our mind, then we will see the Nyquist plot. But whatever may be, any plot, the Nyquist plot or any plot which is the frequency response of, this is the Nyquist plot Now this is, what is the Nyquist plot? The Nyquist plot, which is the frequency response of open loop control system transfer function G of S. This is the Nyquist plot, which is the frequency response of open loop transfer function. All plots are the frequency response of open loop transfer functions. Now before we start the Nyquist plot, now I want to see one concept. Now see here. This is the path. Now earlier also I am saying. Now this is a point X. This is the path and this is the point X. Now if this path is a closed one, if this path is a closed one, if this path is a closed one, this is a path. Now this is a path which is a closed one. Now the total number of n circles. Now this is the point. Now this is the point which is a closed one. Then this point X is said to be. Now the point X is said to be encircled. What I am saying earlier, if any point lies on right hand side of a path and is said to be enclosed, but if that point is in the closed loop, then that point is said to be encircled. There are how many encircles here? See here, only one encircle. Only one encircle. But this is in which direction? Clockwise direction. Therefore, this is plus. Plus indicates the clockwise direction. Where this plus indicates clockwise direction. Where this plus indicates the clockwise direction. Now, this is the point Y. Now point Y is encircled how many times? Only one time. One time it is encircled. But this is in which direction? Anti-clockwise direction. Therefore this is minus. Okay. So this minus indicates, where here this minus indicates the anti-clockwise direction. Where this minus indicates the anti-clockwise direction. Now see here. Now this is the point X. Now point X is encircled how many times? The point X is encircled 2 times. The point X is encircled 2 times. In which direction? Clockwise direction. Therefore plus 2. Now let us take for example, if this is the point, if point Y is here, now with respect to point Y, how many encircle? The point Y is encircled only one time. In which direction? Clockwise direction. Therefore plus 1. Now this is the point X. Point X is encircled how many times? No, not a 2 times. Okay, see here. Now this is clockwise direction. This is anti-clockwise direction. Plus 1, minus 1. So with respect to point X, now there is no encircle with respect to point X. Let us take for example, this is a point Y. If the point Y is here, how many encircles? Now this is one encircle. In which direction? Anti-clockwise direction. Therefore, with respect to point Y, one encircle, but with respect to point X, there is no encircle. Now, why this is encircle? The Nyquist plot is the Nyquist plot or Nyquist plot analysis. The Nyquist plot or Nyquist plot analysis is based on number of encircles. The Nyquist plot analysis or Nyquist stability criteria is based on the number of encircles concept. So the number of encircles concept is, the Nyquist plot is completely depends on number of encircle concept. Okay. Now take down this. This is the number of n circles, how we can identify it. Okay. Now, how this concept is used in the Nyquist plot, we will see. Now, how this Nyquist is saying differently compared with the Bode plot and polar plot, I am already explaining. But without calculating gain margin and phase margin, then how should we identify the stability of the closed loop control system from the Nyquist plot also we will see. This is the Nyquist path. See here. Now what the Nyquist path is saying, the Nyquist path which will cover the entire right hand side of S plane. The Nyquist path which will cover the entire right hand side. Entire right hand side means this semicircle radius is infinity. This semicircle radius is infinity. Now which will cover the entire right hand side of S plane, and the Nyquist path does not include when the poles of an open loop transfer function which lies on imaginary axis. This is the Nyquist path, or let us take this is Nyquist contour of an open loop transfer function. This is the Nyquist path or Nyquist contour of an open loop transfer function. Now, which will cover the entire right hand side of S plane, which will cover the entire right hand side of S plane, and the path is not including when the poles of an open loop transfer function which lies on imaginary axis. Is there any poles of an open loop transfer function? Don't confuse, okay? Is there any poles of an open loop transfer function which lies at origin or which lies on imaginary axis? The path is not included. So why the Nyquist path is not concentrated on the poles which lies on imaginary axis? Because now you tell me when the poles which lies on imaginary axis system is marginally stable. So the Nyquist plot is completely based on the practical application. So now you tell me if this system is a stable system, so what is the decision you are taking? So this is a stable system. Now I am interested to take this particular system. And if this system is an unstable system, so I can also take a decision, I never touch this kind of a system. Is it right or not? So this system is a marginally stable system. Can you take it? No. So we never take practically a marginally stable system whose response is maintained constant and frequency of oscillations. Okay. So I want only a stable system to know that if that stability if you want to find, then it is sufficient. Therefore, the Nyquist plot is completely based on the practical application. He is concentrated, this system is stable, you can utilize. He is concentrated, this system is unstable, then decision is yours. Okay. So that's why the Nyquist is exactly related with the practical application. He is interested to find the system stability, is the system is stable or unstable. Okay, that's why he is not concentrated on the poles which lies on imaginary axis, and practically it is also not important for the marginally stable system. Okay, so this is the Nyquist path or Nyquist contour on of an open loop transfunction which will cover the entire right hand side of S-plane after drawing the Nyquist path. After drawing the Nyquist contour, okay, for a confusion I am saying assume this is Nyquist plot itself, but this plot is drawn for which transfer function? Open loop transfunction. Open loop transfunction. After drawing the diagram for an open loop transfunction, and the Nyquist is searching entire right hand side of S-plane, any closed loop poles available or not, any closed loop poles available or not, Nyquist is searching, finding whether any closed loop poles available or not in the entire right hand side of S-plane. Now after his searching is completed through entire right hand side of S-plane, and finally he is giving a statement that I can search the entire right hand side of S-plane and I cannot find any closed loop poles on the right hand side of S-plane such that the closed loop control system is, tell me, stable. Okay, you understand students what I am saying? The Nyquist plot for an open loop transfer function which will cover the entire right hand side of S-plane such that this radius is infinite, and he is saying that I am searching is there any closed loop poles available or not in the entire right hand side of S-plane, and he concludes that I cannot find any closed loop poles in the right hand side of S-plane, and he gives a statement that the closed loop control system is stable. Sir, how can it possible? Sir, it is possible because this is the open loop transfer function and he is having some poles and zeros. Now, in similarly, closed loop control system is also having some poles and zeros. Whether this open loop control system is converted to closed loop control system, therefore again it is having some poles. Therefore, what he is saying is this open loop control system Nyquist plot is this, but entire right hand side I am searching for any closed loop poles available or not, and there is no closed loop pole on the entire right hand side of S-plane, and he says that the closed loop control system is, he says that the closed loop control system is stable. And some of the students are asking that, sir, Nyquist is finding one closed loop pole in the right hand side. Then you tell me, if any closed loop pole on the right hand side, what you are saying? System is unstable. Now this is the way how the Nyquist is giving and forming a concept. Okay. So he is not depends upon the gain margin. He is not depends upon the phase margin. He is implementing his own method without finding gain margin, without finding phase margin, without gain cross of frequency, without phase cross of frequency. Okay. This is the Nyquist path. Listen carefully. This is the Nyquist path or Nyquist contour which will cover the entire right hand side of S-plane such that this radius is infinity, semicircle radius is infinity, and the path is not including the poles of an open loop transfunction which lies on imaginary axis. Students, you understand or not? So now so the Nyquist plot is always a right hand sided analysis. Sir, why the Nyquist is giving a confusion to us? All are saying left hand side stable, right hand side unstable, but the Nyquist is saying, Nyquist is seeing right hand side and finding the stability of the closed loop control system. Maybe with this particular analysis he may have some other advantages, and I am already saying that the Nyquist will give additional information which is not given by any other plot. Maybe the reason the Nyquist is going in this particular way, in this particular path. Okay. So the Nyquist plot analysis is completely a right hand sided analysis. Understand or not? Right hand side analysis. Therefore, Nyquist is finding one method, his own method. So according to Nyquist stability criteria, according to Nyquist plot analysis, this is called as Nyquist stability criteria, NSC. Nyquist stability criteria. Nyquist stability criteria. And I am already saying Nyquist will implement his own method. This is Nyquist stability criteria without gain margin, without phase margin. So the Nyquist stability criteria is saying that, I am already saying that the Nyquist stability criteria or Nyquist plot is completely depends upon the concept of number of n circles. Therefore, according to Nyquist, the total number of n circles, capital N, which is equal to Nz minus Np. Okay. Now listen carefully. So according to Nyquist stability criteria, or according to Nyquist, then the total number of n circles which is equal to Nz minus Np. Now I am defining each and every parameter. You just listen carefully. Now this is the n. This n is nothing but number, NUMBR, total number of n circles. This is the number of n circles with respect to minus 1 comma 0 point by the Nyquist plot. Now what is the n? N, capital N is nothing but number of n circles with respect to minus 1 comma 0 point by the Nyquist plot. This is the capital N definition. Okay. Now let us take one small example such that you can easily understand. Now my question is, what is number of n circles? Now what is the number of n circles? Now only one n circle. In which direction? Clockwise direction. Therefore n equal to plus 1. See the students, previously it is correct, but now n plus 1 is 100% wrong. This is the wrong answer. Why this is the wrong answer? What is capital N is saying? Capital N is the number of n circles with respect to minus 1 comma 0 point. Then you understand. Angle condition, magnitude condition, Bode plot, polar plot is utilizing angle condition, magnitude condition. Gain margin, phase margin means gain crossover frequency, phase crossover frequency. Gain crossover frequency, phase crossover frequency. If you want to calculate, you want to use angle condition and magnitude condition. Nyquist is not calculating gain margin, not calculating phase margin, no gain crossover frequency, no phase crossover frequency. That is the reason why the Nyquist is choosing a point condition. This is a open loop transfer function with respect to minus 1 comma 0 point is nothing but 100%. It is a link of a closed loop control system. But where is minus 1 comma 0 point? But this is positive real axis. Minus 1 comma 0 point is not here. Minus 1 comma 0 point is always on the negative real axis. This is minus 1 comma 0 point. With respect to minus 1 comma 0 point, is there any n circles? No. So here 100 circles not used. Only the circle is with respect to minus 1 comma 0 point. Now n equal to 0. This is correct. This is 100% wrong. Understand or not? Note down this. Clear? So you should always define the number of n circles with respect to -1 comma 0 point, not somewhere. Understand or not? Okay. So concentrated while identifying the number of n circles with respect to -1 comma 0 point. Then, sir, then what is NP? Now see here. Now this is NP. NP is nothing but again number of right hand sided open loop poles. Number of right hand sided open loop poles, where NP is number of right hand sided open loop poles. Okay, what is NP? Number of right hand sided open loop poles. What is the meaning of that? Because Nyquist analysis is completely based on the right hand sided concept. G of S, which is equal to K into S plus 2 by S into S plus 1. How many poles? 1, 2. Therefore, NP, which is equal to 2, 100% wrong. What is NP? Read once again. NP is number of right hand sided open loop poles. Now, in this particular example, where are the poles? One pole is at origin, one is at one pole is at -1 and 1 0 is at -2. Is there any right hand sided open loop poles? Now see here. And open loop poles at origin, Nyquist path is not including. So is there any right hand sided? No. Therefore what is NP? NP equal to, all are left hand side, no is on right hand side. NP equals 0. This is right, this is wrong. Note down this. This is NP, number of right hand sided open loop poles. But all these poles are on the left hand side of this plane. Therefore, there is no right hand sided. Okay. And the Nyquist does not include the poles which lies on imaginary axis. Or for example, if it is like this, G of S, which is equal to K into S plus 1 by S into S minus 2. Now see in this case, in this example, one pole is at origin, 1 0 is at -1, but one pole is at plus 2. Now the Nyquist path is entire right hand side of S plane, and not included the poles which lies on imaginary axis. Now see what is NP. How many right hand sided open loop poles? What is NP? How many right hand sided open loop poles? How many right hand sided open loop poles? NP is number of right hand sided open loop poles. How many are there? Only one. NP equal 1. This is correct. Understand or not? Now this is NP is 2 because 1 and 2 you are counting. This is the wrong way. If you take NP as 2 here, this is wrong. NP is 0. This is correct. Okay. So NP means not total number of poles. NP means number of right hand sided open loop poles. Okay. Note down this. Clear or not? Now this is the way you can find capital N and NP. NP means open loop transfer function, right hand sided open loop poles. So there is only one parameters are left here. Now this is number of right hand sided Now what is NZ, right? I want NZ. What is NZ? Now the NZ, which is nothing but number of number of right hand sided, where NZ is, now what is NZ? NZ is number of right hand sided, number of right hand sided closed loop poles. Now what is NZ? NZ is number of right hand sided closed loop poles. Sir, Z means zeros, but you are saying here NZ is number of right hand sided closed loop poles. Now how, sir, how these two are related? Now that's what I am giving one small example. You just listen carefully, okay? Now, open loop control system, G of S, okay? Now in open loop control system, now I just take zeros of open loop control system. Okay, listen carefully. Now first step I am taking zeros of open loop control system. Now second step I am taking right hand sided zeros. Right hand sided zeros of open loop control system, which means there may be zeros in open loop control system and that zeros may be on right hand sided. Okay. Next, third step I am saying number of right hand sided zeros of open loop control system. Maybe how many zeros are on right hand sided in open loop control system. This is the statement. How many zeros in the open loop control system? Which side? Right hand sided. Okay, there may be a statement like this. But now you just observed here, whenever, listen carefully, whenever G of S is with respect to -1, 0 point. What is the meaning of that? G of S is with respect to -1, 0 point is nothing but G of S equal to -1 plus J0. If you come this side, 1 plus G of S, which is equal to 0. This is nothing but a characteristic equation which is completely deals with closed loop poles. Okay. Now this is the open loop control system. When you studied the open loop control system with respect to -1, 0 point, that is not the open loop control system. That is totally deals with closed loop control system. That is totally deals with characteristic equation. That is totally deals with closed loop pole. Now similarly, see the students here, open loop transfer function zeros. Now open loop transfer function right hand sided zeros. Open loop transfer function right hand sided zeros, how many in number? But whenever this open loop control system transfer function is with respect to -1, 0 point, this open loop control system transfer function with respect to -1, 0 point, this open loop control system transfer function with respect to -1, 0 point, whenever it is with respect to -1, 0 point, this is not a open loop. This is a characteristic equation. It consisting only closed loop pole. Therefore, this is the exact meaning of NZ. Now read NZ. What is NZ? NZ is nothing but number of right hand sided, Z stands for zeros, of open loop control system. Up to this is the statement is clear. But when this open loop control system with respect to -1, 0 point, no open loop, nothing, only closed loop. That is the reason why this is exactly same as that of number of, can I write like this? Number of right hand sided, number of right hand sided. Now G of S with respect to -1, 0 point is nothing but only closed loop poles. This zeros is now named as closed loop poles when this G of S is studied with respect to -1, 0 point. Listen one point very carefully. Whenever the open loop control system is discussed with respect to -1, 0 point, it is not an open loop, it is 100% it is closed loop. Number of right hand sided, that's why this is nothing but closed loop poles. Now these two are exactly same. Now this meaning will be exactly same as that of this. That's why if this is NZ and this is equivalent. Therefore, this is NZ. That's what I am writing. NZ is nothing but number of right-hand sided closed loop poles. That is an easy definition. Now, in internal definition is number of right-hand sided zeros in open loop transfer function, but with respect to -1, 0 point. Understand, student? Okay, this is very, very important definition. If you understand this, then you can easily understand the Nyquist plot. Okay, note down this and take this is the according to Nyquist, the number of n circles is this. Now you tell me here. Now, according to Nyquist, if nz equal to 0, what happen? If nz equal to 0, closed loop control system is 100% stable. Why? If nz equal to 0, what is the meaning of that? If nz equal to 0, there is no closed loop poles in which side? Right hand side. There is no closed loop poles on right hand side. All the closed loop poles on left hand side, such that the closed loop control system is stable. So if you want a closed loop control system to be stabilized, then in these parameters nz must be 0, which means that if nz means 0, which means there is no right hand sided closed loop poles such that the closed loop control system is stable. If you understand these three parameters, the Nyquist plot will be the easiest plot. No doubt. Okay, then if you understand these three parameters, the Nyquist plot will be the easiest plot. Now let us start solving of one small problem such that you can easily understand. Okay. So now what is the question is given is, by considering the transfer function g of s equal to k into s plus 2, g of s equal to k into s plus 2 by s into s plus 1, g of s equal to k into s plus 2 by s into s plus 1, g of s which is equal to k into s plus 2 by s into s plus 1. By considering the transfer function, what should be the number of n circles? By considering the transfer function, what should be the number of n circles such that closed loop control system is to be stable? This is the statement which is given. So, by considering the transfer function, what should be the number of n circles such that the closed loop control system is to be stable? This is the question he is asking. Now you tell me, now number of n circles means n equal to nz minus np. np we are finding from number of right hand sided open loop poles. Number of right hand sided open loop poles. How many right hand sided open loop poles? There is no right hand sided open loop poles. All are lies on left hand side. One pole at origin, one pole at -1, 1 0 is at -2. Therefore, is there anybody is on the right hand side? Nobody is on the right hand side. Therefore, np which is equal to 0. Therefore, this is 0. Now, what is nz? nz is given in the question because he says that number of n circles such that the closed loop control system is stable. Just now I am saying that if the closed loop control system is stable, nz equals 0. nz means there is no right hand sided closed loop poles. No one closed loop pole. None of the closed loop poles are available in the right hand side. All in the left hand side, such that the closed loop control system is stable. Therefore, closed loop control system is to be statement is given. Therefore, nz equal to 0. Therefore, nz equals 0. Then asking is what should be the number of n circles? The number of n circles with respect to -1 comma 0 point is 0. This is the correct answer. Like this, there may be questions, okay, small questions. Note on this. Now one more question. Now by considering the transfer function g of s equal to k into s plus 2 by s into s minus 1. Now again the same question. What should be the number of n circle such that the closed loop control system is stable? So number of n circle means n. N equal to nz minus np. Np means number of right hand sided open loop poles. Is there any right hand sided open loop poles or not? You can cross check. Now one pole is at origin and one pole is at origin and one 0 is at -2 and one pole is at +1. See here, what is NP? Number of right hand sided NP. What is NP? Number of right hand sided open loop poles. How many right hand sided open loop pole? NP equal to 1. NP equal to 1 minus NZ. Closed loop control system is stable. Closed loop control system stable means NZ equal to 0. NZ equals 0. Therefore, what is capital N? Capital N, which is equal to -1. So what is the meaning of that? So the total number of n circles with respect to -1 comma 0 point is 1. So let us take for example, maybe example like this. -1 comma 0 point is like this. So n circles, how many times? 1 time. But in which direction? Anti-clockwise direction. So what is the meaning of that? -1 comma 0 point is n circle 1 time. But in which direction? Anti-clockwise direction, -1, for example. Okay, like this. No. Okay, like this, a small questions. Okay, first of all, you want to understand the parameter, which parameter is given, which parameter you want to calculate. Okay, now one more question is one small question. Open loop control system is unstable with two right hand sided poles. Open loop control system is unstable with two right hand sided poles. However, the corresponding closed loop control system is to be stable. However, the corresponding closed loop control system is to be stable. Then what should be the number of n circles? Then what should be the number of n circles? Here is options are also given. Here the options are also given. These are the options. Okay. Now, these are the options. Now see here. Open loop control system is unstable. Why the open loop control system is unstable? Because the open loop control system is having two right hand sided poles. What is the meaning of that? The open loop control system is unstable with two right hand sided open loop poles, which means here one statement is given np equal to 2. Am I right? Not np equal to 2. But however, the corresponding closed loop control system is stable. The corresponding closed loop control system is stable, which means that nz equal to 0. Which means that nz equals 0. Then he is asking what should be the number of n circles. The number of n circles equal to nz minus np. So n equal to nz is 0. np, open loop control system, is unstable with two right hand sided open loop poles, which is equal to 2. N equal to minus 2. So the total number of n circles. What should be the total number of n circles? The total number of n circles are 2. He is not giving the direction. If given the direction, take anti-clockwise. Otherwise, take this one directly.